All right, guys, welcome to lesson 31-2, applying rating measure. But I wanted to review yesterday really fast. At the end, I think I was kind of quick. So to find arc length, this is just yesterday's lesson. There's two ways to do it. If the question gives you the degree, one way you can approach it is doing the formula 2 pi r times arc, and then some books might say angle over 360. I said arc. It's the angle of the arc. And then another way is to do if they give it to you the radian, and that would be, remember, S equals theta times R, or R times theta. So like, let's do one, it'd be like 45 degrees. So if they give you 45 degrees, let me look at the notes. Did we do 45 yesterday? I hope we did not. So if we change it, I'm gonna do one that we did yesterday. Let's do 90 is really easy. So do 90 degrees. So if it's 90 degrees, it'll be 2 pi, and we'll say R is 4. 90 degrees, and R is 4. And then it'd be 90 over 360. So it'd be 8 pi times 1/4, or what is that, 2 pi, right? Okay, so that's if they give you 90 degrees and then the radius is 4. Okay, let's give you the same thing. Radius is 4. Well, then they're going to say the radian theta is pi halves. Because pi halves, you look at yesterday's notes, pi halves is equivalent to 90 degrees. So it'd be arc length is equal to theta times 4, which is 2 pi. Okay, so it's same information. This is just in degrees. This is in radians. But yesterday we talked about radians is the measure of the angle in terms of the length of the arc for that measure of the angle. So 90 degrees and pi halves are the same thing. One's in degrees, and this one's in radians. So on your calculator, if you use your calculator, you'll know there's a mode. There's degree mode, which I know you've done this in geometry. Make sure you know you're in degree mode when you're working with degree. Okay, so on your calculator, make sure you're in degree mode if you're working with degree. If you're not, then you can just leave it as normal. So again, these are the same thing, just written in two different formats. So hopefully that makes sense. If not, email me and I will reteach it again and do another video or come to our office hours. Okay, so then today I kind of already taught this, so we can go kind of quickly. Actually, so that's awesome. Let's see. So sorry, I'm wasting time. There. Okay. Okay, it says angle measures can be given in degrees or radians. So I've kind of already talked about all this, so maybe you can go kind of catch on. Okay, so angle measures given degrees or radians, which we just reviewed. Okay, so in lesson you found that 180 degrees equals pi radians, so important. Okay, what ratio do you multiply radians by? So we said if you're given pi, you multiply by 180 over pi, which would give you 180 degrees, which makes sense. So 180 degrees is pi radians, and we just proved it because this is the conversion. So then it says, does the ratio also help you to convert pi halves to 90? So if we say pi halves times 180 over pi, the pi's cross out, so you get 90. So yes. Okay, can you convert an angle measure given in radians to degrees? So this is review. I kind of taught ahead yesterday. So radians, 2 degrees. The conversion factor is 180 over pi, which is 1, right? Because 180 degrees, because remember yesterday we talked about this is 180 degrees and it's also pi. Then we have degree to radians, and you would multiply by pi over 180. Okay, make sure you know these conversion factors. You'll definitely use these a lot in pre-cal. Okay, convert the following angles in radians to degrees. So pi phys would be 180 over pi. Pi's cross out. Pi goes to 180 36 times. That's a degree. Okay, then times 180 over pi. Pi's cross out. 4 goes to 180 45 degrees. And I stop there because 2 examples is good. Okay, sometimes angle measures are greater than 360 are also given in radians. Okay, so it could be any radian measure. It doesn't matter if it's less than 2 pi or greater than pi. It doesn't matter. So 7 pi thirds, same thing. 180 over pi. The pi's cross out. Well, 3 goes to 180. What, 60? 60 times 7 is 420 degrees. So you're probably saying, what does that look like? 420 degrees. So let's draw a picture. So if you go around the circle, that would be what? 360, and then 60 more would be about 420. So it looks like that. So where did you stop at? If you go back to yesterday's lesson, if this is 60 more, then that would be you're stopping at 60 degrees, which is pi thirds. So that's where you're ending at. So that's from yesterday's. So if it's greater than 360, you're obviously going to go around the circle more than once. Okay, 6 pi halves times 180 over pi. Pi's cross out. 2 goes 180, 90 times 6 is 540 degrees. Okay, what does that look like? So you have 360 degrees. Well, 360 plus 180. 180 is 540. So this right here is 540 degrees. Okay, so where does it stop at? It stops at, on like the unit circle, 180 degrees. So it stops at pi, because this is 180. So it stops at pi. So going around shows that it's 540 because I go around the circle and then stop there. It's a total of 540. But if you're just thinking between 0 and 360, it's stopping at the 180 part. Okay. Given an angle in radian measure, how can you determine the degree measure is less than or greater than 180? If it's greater than or less than pi. So if it's greater than or less than pi, then it's going to be greater than or less than 180. Given an angle in radian measure, how can you tell the degree measure is greater than 360? Well, if it's greater than 2 pi. Because remember, 180 is equivalent to pi, 360 is equivalent to 2 pi. Let's see, what else? The Greek symbol theta is often used to refer to an angle measure. We talked about that already in the intro of the lesson. And then, let's see, it says, write a formula to find the arc length s traveled at a diner in the restaurant for any radian angle measure in any radius. So arc length s, measure theta. So we just went over that at the beginning of the lesson. So I said s equals theta times r. Good to know. Okay, so from the beginning of the lesson, here, talked about you can give it in degrees. This formula might be a little bit easier. If you're given the measure in radians, then this formula is definitely easier for sure. I will tell you that in pre-cal, this is the formula we use a lot. Okay, last thing, approximately how far will a diner seated at a radius of 20 feet travel updating for 1 hour and 20 minutes? The designers decide the restaurant should do one complete rotation in every 40 minutes. So every 40 minutes, you go one rotation. So the radius is 20. Got that. Then it says, so in 40 minutes, how far have you traveled? Well, 40 minutes is one rotation. Well, one rotation is around the circle. Well, that's equivalent to 2 pi. You've traveled 2 pi. The distance you've traveled is 2 pi around the circle. Then you can do another 40 minutes. So now we're up to 80. You've traveled another 2 pi. Right? So it's 80 minutes. How far do you want to go? Hour and 20. Hour and 20 is what? 80 minutes, right? So 60 and 20. That's what we're doing. So there's 80 minutes, which is an hour 20. So I've traveled 4 pi around the circle. Okay, so hour 20, 80 minutes. So then I'm going to use this formula, S equals theta times R. So theta is how far did we travel? Theta is 4 pi. That's theta. R is, what is it, 20? So a good answer is 80 pi. That would be an exact answer. This would be an exact answer, right? Or if it says round, that'd be 251 point, let's type in the calculator, 33 feet. Okay. So if you did not write this down from the beginning of the lesson, it was just a review, maybe you might want to go back and write it down because it's a good reference to how they're the same thing, but it's just different. One's in degrees, one's in radians, but it's the same answer. So you might want to go back and rewrite it if you skip that part. It's up to you. There's plenty of room on the notes here. So that is all I have. I will see you in office hours. You already have the homework assignments. That's awesome. And don't forget there is a quiz tomorrow. So I will talk to y'all soon. Okay.